Welcome to another edition of Beyond the Headlines. This is a series that we periodically do when preeclampsia topics have really captured the attention, extensive attention of the media, and we really want to get into the details and understand what's behind the story, talk to maybe one of the key players in the story. And so we're super excited today to be talking to Dr. Tom McElrath, who is a professor at Harvard Medical School. He's also an associate professor in epidemiology at the Harvard School of Public Health. He is a practicing OBGYN, specifically a maternal fetal medicine specialist, practicing at Brigham and Women's Hospital in Boston. The name of the paper that we're going to be digging into is called RNA Profiles Reveal Signatures of Future Health and Disease in Pregnancy. And it was just published in Nature, just in January of 2022. Nature, of course, is an extremely prestigious medical journal. The media does tend to, I will almost say, overdo coverage of anything that's in a high-profile journal. This has gotten a lot of attention. That said, there are some really cool things about this research that we'd like to unpack for our viewers. Now, our viewers are a lay audience for the most part, but bright and highly interested in understanding what is happening in the world of preeclampsia. So let's start with just understanding the RNA aspects of this, which tend to be, as I understand it, one of the cooler, newer aspects of what this study is bringing to the table.
So first, thank you very much for the opportunity. I mean, the ability to speak to an educated audience is just every clinician and scientist's dream. So once again, thank you. RNA in this context. So let's just step back a minute just to recall what RNA does. It is involved in the expression in gene expression, and typically we all learned in high school RNA goes on to become protein in the classic sense, but much more recently we've since learned that it actually is involved in how one cell may attempt to modify the behavior or the environment with other cells. So RNA will be expressed by one type of cell without the intention of it becoming protein, with the intention of it actually going on to modify the behavior of another cell or modify the genes that are expressed in another cell type. So the best way to think of it in this context, where we were looking at what's called cell-free RNA. So we were looking at the RNA that was in a woman's, in her plasma, in her circulatory system, obtained through a simple blood test. But the best way to think of it is a census of what genes are being expressed. So it is really just a way of looking at what genes are turned on and are active at a specific time in pregnancy.
And so when we think about, again, sort of the unique, what's new to the field, what is this study bringing that's new to the field? It's not only the fact that we're looking at RNA in sort of a new way, but potentially the discovery of new molecules or new genes or genetic signatures that indicate that something's wrong in the placenta. Is that part of what we've unpacked with this?
It's a part of it. It's the really big piece that I think this study brings to the field is the idea that we can now map normal gene set expression as a pregnancy progresses. So the idea that with the progress of time and gestational age, we can start to look at what patterns of genes are being turned on and being turned off. Think of it in your mind maybe as I'm going to go week by week, but certainly we can be a lot more refined than that. There might be a kaleidoscope of genes in 1 week that are turned on and turned off. And the next week, there might be a similar but slightly different kaleidoscope of genes that are turned on and off. And the next week, a similar but slightly different kaleidoscope from that. And we can march all the way through the pregnancy that way. And so this suddenly allows us to do a couple of things. First, and perhaps most obviously, we can tell how far along the pregnancy is when a sample is obtained. If we know the pattern of genes that are turned on and off at a specific point in pregnancy, now we suddenly have another another clock, another way of looking at how far is this pregnancy. And you might say, well, why do we need that? We've got ultrasound, and ultrasound's pretty good. And that's true. But we were able to show that in the second and third trimester, this test is as good as ultrasound, and perhaps even in the third trimester, a little bit better. So it offers us a whole new potential area for investigation in just clinical obstetrics. Now, equally importantly, we were seeing evidence of genes that are expressed in the placenta, as you mentioned. In the mother, that makes sense. It's her blood. It makes a lot of sense that her genes are there, but also interestingly from the baby itself, suggesting that these were signals that were being passed across the placenta, probably purposefully, although that area of research is still ongoing, but that we are picking up in the mother's blood signals of gene set expression from the baby itself. So that becomes exciting because now we can actually start to look in on the health and well-being and developmental well-being of the baby itself. So what this project really was an attempt to map normal pregnancy, normal gene set expression with pregnancy, and then start to think about, well, how can we use that technology? And one way to start to use it is to look at what deviation from normal may be. And this is where we chose preeclampsia as our first case study, basically. So we began to look at women who went on to have preeclampsia. How did their gene set expression differ from those who didn't? And we were able to see as early as 14 weeks prior to the diagnosis of pregnancy that there were already differences. So it's almost as if we had a roadmap, and then we could tell some patients start to deviate from that roadmap as early as 14 weeks on average prior to the diagnosis. So it allows some time to prior to clinical diagnosis. It's tempting to think of this as a preeclampsia only test, and of course that's a very important function, but we hope to expand it into other complications in pregnancy, perhaps preterm birth, gestational diabetes, and then, as I mentioned a minute ago, very excitingly, also perhaps health aspects of how the baby itself is doing, and that remains to be seen. But that's a very exciting area as well.
Well, and of course, the interesting aspect of this clinically is that if we can identify those women who are kind of going off the roadmap early in pregnancy, that we then can intervene with some kind of a therapeutic method to bring them back onto the map and hopefully eliminate or mitigate any dysfunction that's affecting either the development of the baby or the mother's health. And I think that's where there's been so much interest right now in predictive or screening tests, because the question then becomes, well, what can we do about it to course correct? But I think one of the other things that that sometimes gets lost in this conversation is not the clinical utility, but the research utility, because the what can we do for them is rather limited. I mean, we've talked a lot about aspirin. We know that helps certain women, but it's not all women who develop preeclampsia can be helped by aspirin. So clearly there's more that needs to be done in the therapeutic department. So let's talk a second. I want to come back to that, but before we do, as a screen for preeclampsia, as a prediction of who's going to develop it, this is not the first time somebody has introduced an idea of how can we better predict preeclampsia. So let's talk a little bit. I know there's this concept in the paper and many papers about this, talking about the positive predictive value, the PPV, which is essentially, as I understand it, the chance of a test predicting an outcome in a certain population. And it's important to understand that what this paper is reporting is that this is significantly better, that the PPV in this approach is significantly better than some other tests. So for the lay audience, you know, an example of a PPV would be something like a Down syndrome test, which the PPV is so positive, so strong, something like 95% accuracy in the positive predictive value of a Down syndrome test, that it's now seen as a clinical, I mean, that's so solid, it can be used clinically. But that's looking at 95% of women in a general population and who's going to develop Down syndrome, which babies are going to develop Down syndrome. So talk a little bit about the PPV in this test or in this study, and who is the population that was studied?
So this study was a group of women who we knew went on to have preeclampsia, and then a group of healthy, normal women. So it was what you might call a case control study. The data was derived from a broad swath of human experience. We had data sets from North America, from Europe, from the UK, and then interestingly as well, also from Africa. So this wasn't sort of an isolated study from one center. It was quite generalized to human experience. Now that the material that was used to look at the preeclampsia was a little more narrowly from two cohorts that are in North America, but it was women who we knew went on to get the disease, comparing their samples against women who we knew would not get the disease. So in some sense, we were really optimizing success at that point. I mean, that is as good as the epidemiology could get. You know they have it, and you know they don't have it. You're right. As this becomes more generally available in the general population, the positive predictive value or the strength of the test is likely going to change as there's more out there. There's more noise in the system as it's used sort of under normal clinical circumstances. But that's one of the reasons why this is still in development. This is not ready to go into the clinic in the next month or so. It still needs to be demonstrated, the parameters of the test's use in a normal clinical population. However, as you point out, their positive predictive value, which is about 33% here, is much higher than the positive predictive value for what we have clinically at the moment. Unfortunately, most of our predictive value for clinical preeclampsia is based on whether a woman has had preeclampsia in the past, and that really doesn't help with those 30% of women who are having their first pregnancy.
Right.
And yeah, I think the positive predictive value for the standard clinical risk factors based on a woman's characteristics and her past pregnancy, if she's had a past pregnancy, is about 7 or 8%. So we're actually doing much better with the 30%, although we'd all like to see that become higher than it is. But this is about what you get for a screening test for most types of cancer as well. It's not an unknown positive predictive value in the screening, in the epidemiology of screening tests. And I think that's an important distinction. This is a screening test. This shouldn't be thought of as a diagnostic test. This is just telling us that you're at higher risk and someone else may be at lower risk, just the way your cholesterol may be higher versus lower, but that's not saying you're going to get a heart attack or other screening tests that are used in standard medicine.
Yep. You mentioned that the optimization of it because you knew women were going to get preeclampsia. There's a lot of talk in the field right now around the heterogeneity, meaning the diversity of manifestations of preeclampsia, early onset, late onset, preeclampsia associated with fetal growth restriction versus no seeming effect on the fetus. Potentially different pathways for moms who have really high BMI versus normal BMI. Like there's all this conversation around the heterogeneity and the fact that a lot of the signals that we're looking for may be muted by the fact that we're throwing too many things into the bucket. And I'm wondering, how did the study group deal with that issue? Was it all preeclampsia, and what might effect does that have, the way it was, how you all defined it, on the results?
So I think as someone who practices in the field, or you can't spend much time practicing in clinical obstetrics before you begin to realize that preeclampsia does have many different presentations. It looks different in a patient who has it at, say, 28, 29 weeks than it does at someone who has it at 37, 38 weeks. it really frequently has a much different clinical presentation and a much different level of severity, and of course, much different consequences for the baby itself in many cases. In this case, we were looking at earlier preeclampsia, more likely to be a homogeneous presentation of the disease, and therefore we were more likely to find a signal. But I think, given what you just mentioned about the heterogeneity of the disease, that was our only criteria. And the fact that we found something is optimistic that there is likely to be more out there to discover. And that's one of the next places to begin to go with this type of work is, can we begin to look at the type of preeclampsia? Does it differ from one patient to the next? Might one patient be at risk for a, say, late preeclampsia and another patient be at risk of an earlier preeclampsia? And then to extend that and begin to look at, might, say, aspirin be more amenable to one patient and then perhaps another therapeutic be amenable to another? And can we really start in the near future, can we really start to personalize this down to a level of not just treating a patient because she's at risk of preeclampsia, but treating her because she's at risk of her version of preeclampsia? And that's really where I think this technology allows us to begin to go.
Absolutely. Well, let's talk about that. Put this research into the context of the development timelines for screening or diagnostic tests. And I should probably mention as an aside that the good news in what you all have done is that fortunately there's a company, Mervi, out of San Francisco, and which is always good, because when you've got somebody investing real dollars in this, I mean, sometimes great research gets stuck in the academic cycle and never transitions to a place where it can actually move forward. And we probably should disclose that that you and a few of your co-authors do have financial equity in that company. And I think it's important that we understand that disclosure. But you know, what does good quality research, taking that approach with this, what are the next steps? What needs to be done now to make this a research useful tool, and then ultimately a clinical or a clinically useful tool?
So I'm going to, you know, I am a physician and scientist, and how you bring a test to market in business is an area that I'm very, very new to at this point. So let me begin with that caveat. The first thing is it is a test that's in development, and to, as I mentioned earlier, to see how it performs in a prospectively collected population of normal patients, of patients receiving regular prenatal care, as opposed to in the more controlled environment of our study, is the next step. How one then goes through the FDA to receive certification and what that might involve, that's beyond my pay grade at this point. And I think if I wish to say anything, I may actually be, you know, perhaps misleading rather than informative on that stage. But that would be the next step, is more prospective validation of the test, which is ongoing at the moment, and then a conversation with the FDA about the steps that would be involved to proceed up to that.
And when you say prospective evaluation, I mean, I think, you know, understanding that research that looks backwards at what would this have done if we had studied this in XYZ population often produces very different results than if we look at, let's just drop this into the big unknown of real world and how will this perform. And this is where your point about the subtypes of preeclampsia could really make a difference, because it may not have a signal when you look at a very general population. I mean, the prevalence of preeclampsia in a general population is relatively low, but then starts getting, you know, ratcheting it up when you start adding higher and higher risk factors. It's interesting you mentioned that this could also identify other placental pathologies, and whether it be preterm birth or I don't know, you know, how wide the field is of other pathologies. If you start combining other complications into this, is it not possible that all women would end up screening for something going wrong, or is it likely to be, are there likely to be different versions of a screen to identify different pathologies?
That's a really interesting question. Our goal down the line, and I'm going to be vague about how far down the line we can discuss, is once again to be able to, at the beginning of a pregnancy, say at the first prenatal visit with a simple blood test, begin to predict for a woman, what are your risk factors? What might your risk factors look like in this pregnancy? And perhaps you may not be at risk for preeclampsia, but perhaps you might be at risk for spontaneous preterm birth, or perhaps you might be at risk for gestational diabetes. But if we could start to tell this very early in the pregnancy, then therapeutic steps might be able to be implemented earlier in the course of the pregnancy for any of one of these number of conditions. I don't think we'll ever get to the stage where there are so many tests out there that will find something on everybody. I think that it's reasonable to suggest that there will be a handful of major conditions in pregnancy, and we'll be able to risk profile each patient as she comes in. But if you think about it, that's a lot of what goes on in the cancer literature right now, that as a patient comes in with a diagnosis of, say, breast cancer, the specific conditions of her breast cancer can be tailor-made to her situation, the type of cell, the type of receptor, the type of tumor genome, and so forth. And then her therapy can be very specifically designed. This is a concept called personalized medicine, and I don't think there's any reason we shouldn't be able to expect that in pregnancy as well.
Right, absolutely. Well, let's talk. I mean, the good news here at the end of the day is that this is advancement in the field, and anything that drives research in preeclampsia is always a good thing. And we've suffered from decades of lag in research in this area. So we're of course thrilled to see any kind of movement, and this is great. I do think that one of the things that does tend to get lost with some of these discoveries as a potential screening tool is this idea that one of its greatest benefits may be to the research field itself, and the fact that it could help identify women at the highest risk for developing preeclampsia and getting them into clinical trials for investigative drugs and methods to prevent preeclampsia, so that all women aren't unnecessarily exposed to these trials. Plus the fact that they're just expensive to do. We'll never get those kinds of trials done if we're always trying to enroll a general population. So I don't know if that's part of the mindset that this study group has had, or if you're just looking at it through the clinical lens.
Well, I think there really are three, if you think about it, three separate sets of benefit that the development of this type of test will bring. First is probably to the individual herself. We mentioned that earlier, that should someone perhaps be on aspirin if she's at higher risk, well, fair enough. That seems to be a relatively straightforward prophylactic. There's some discussion in the literature about maybe other anticoagulants might also be prophylactic as well. Should that patient be moved to a higher risk clinic? There are things we can do with the individual if she were to screen positive, including empower her to begin to take charge of what this diagnosis may mean. And that may be something as straightforward as taking home a blood pressure cuff and virtually send us your pressures every week. Just simple modifications of prenatal care that may allow an earlier diagnosis, a earlier administration of prophylaxis, say betamethasone in the case of trying to prevent the consequences of prematurity in the baby, but just knowing what might happen earlier and help the mother and baby out sooner, even if we don't yet have a therapy to intervene on. The next level is at the logistic level. It's easy enough. I'm sitting here in Boston, and there are plenty of MFM doctors around, but there are parts of the country where there are very few MFM doctors around, or very few high-risk clinics. And logistically, maybe we need to begin to think about, in those circumstances, how might the patient be, if not moved, at least facilitated, that she might have access to these kinds of facilities before the disease becomes apparent. So just even to think through the process ahead of time. If you flip it around, it would also be useful for the hospital to know this is what our preeclampsia risk profile looks like over the next couple of months. You can imagine that that might be useful in helping the allocation of hospital and administrative resources. But I think the final area where this test will be useful is the one you've already outlined, is in the utility of research going forward. And there's a couple areas where that will become important. The first one is, as you mentioned, these studies are hard to do. Preeclampsia occurs roughly at about 7% of our population. So if for your new drug or your new therapeutic, you need 1,000 patients with preeclampsia in a trial, that's a very big trial, might take a long time and be very expensive. With this test or this type of technology, we can begin to screen patients for a trial and make those trials not only more efficient, but also faster. And I think that's an important piece. But there's a piece beyond that, which is even, I think, more exciting. And we sort of alluded to it in our earlier conversation, which is the types of preeclampsia. In this paper, we identify 7 genes that seem to be important in predicting a patient's risk of preeclampsia. Once we start to know more about these genes and more about the pathways in which these genes act biologically, might it be possible to identify a medication that's already out there that influences one of these pathways? That might be a very easy first step to thinking about a new novel therapeutic for preeclampsia. Might it be possible, failing that, to go forward and start to look at what would it take to modify one of these genes in one of their pathways? That would be the development of an entirely new medication. So not only to begin to tell who might get what type of preeclampsia, but the process of this discovery begins to suggest some of its own solutions about what it might take to actually modify how this disease presents as a risk. Now, that's longer term, but that's really the exciting stuff about how this is going to move forward.
Absolutely. And I mean, when I made the comment about, any research in this field is good, I think that the discoveries of these new genes and that's going to encourage, I think, the field of researchers to dig deeper. And there's a lot more. This is the beginning of a lot more research that can be uncovered, because ultimately, the big unanswered question is what causes preeclampsia. And we love to just say, well, we still don't know. What we are discovering are the multiple pathways that are leading us to the answer, and we may have some solutions just based on some of those pathways toward the answer. So super exciting, super congratulations on being part of a great team that's done some great work. We're going to be keeping an eye on this very closely and seeing where this goes. I think, I'm going to ask for one last word from you as more of an admonition to the field, which is, what are your thoughts about the current standard of care for predicting who will get preeclampsia? And as a result, how important is something like this work to the field, to the current practice of care for pregnant women?
Unfortunately, I think our current ability in clinical practice to predict preeclampsia is pretty much the same as it's been for the last decade, 2 decades. I don't think we've really had a lot that's been a dramatic and notable improvement. There have been some improvements. There's been the realization that certain maternal characteristics may be associated with an increased risk of preeclampsia. But as I mentioned earlier, it's been so nonspecific that it really is hard to personalize someone's care based on those characteristics. This ability to begin to refine that is really what becomes exciting. And I think, I mentioned to my residents that I think the way they will practice prenatal care and obstetrics when they get to the stage of career that I'm at right now will be much different than the way we practice right now. I think all of this is a great time to be involved in not only medical research, but particularly research in women's health. And things are really beginning to start to move. There are several groups looking at therapeutics, medications for preeclampsia. There's several groups looking at different types of predictive tests, as well as all the basic research you alluded to earlier. So this is really an exciting time to be in this field.
Awesome. Thank you so much for taking time to talk with us today. This is another episode of Beyond the Headlines, and we've been talking to Dr. Tom McElrath out of Boston. We're super grateful for your time and for your investment of time in research in such an important area. So thank you so much.
Bye-bye now.
Bye-bye.